Okay, I'm recording the exercises. So what we did yesterday, guys, we did section 7.2, we did section 7.3, and I ended our discussions with one question from 7.4. Well, I'm going to continue. I'm going to go back and do more exercises from section 7.3 when we test the claim about the mean when sigma is not known. That means it's not given, it's not provided to us in the problem. And let's do some more exercises. And then we'll go to section 7.4. And I think I have 4 or 5 questions, from this section. So we'll do plenty of those.
Professor,
Yes.
are we going to go back and touch base on like finding the critical values?
Yes. But that's going to be, that is in the plan as well. It will be on the test. You will not see any questions pertaining to critical values. It's just, I'm going to show it to students that there is another approach, just to solve problems using critical values.
Yeah, I think it was on our homework. That's why I just wanted to touch base.
There is probably one question on the homework, and I think I didn't intend to put it in there, but I'm going to touch on it. Yeah. On the test, it will be the p-value approach, guys, which is what we're going to strengthen today. The amount of water consumed per week by Montana residents is normally distributed with a known mean. A simple random sample of 26 residences, so n is 26, has a mean value, x bar is 120.3. When he gives you the mean, he's giving you x bar, guys, remember that. And a standard deviation of 10. He didn't say a population standard deviation, he's talking about the sample, guys, so this is S. The city of Bozeman claims, now guys, this is the question, that the average water consumed in the state of Montana is not 125. Can you guys help me write the null in the alternative?
Mean is not equal to 125 for the HA.
And that's the claim. You agree? Yeah. Okay. This is, guys, if S is given, this is a t-test. So we're just going to go to the t-test right away. And what the t-test is going to give us is going to give us two values. One is called the test statistic, and one is called the p-value. So you just go to test.
Why is this one t-test again?
What is it?
Why is this one t-test?
Because S is given, the sample standard deviation. When he gives you population standard deviation, it's a z-test. When he mentioned S and not sigma, it's a t-test. And that's very important, guys. From my experience teaching, statistics for so many years, this is where students get confused between these two. Whether you're using calculator or not, whether you're using critical values or not, they get confused. Do I use Z or do I use T? You use T when he provides a sample standard deviation and doesn't provide a population standard deviation. You use Z when he provides population standard deviation. And we will have some more review exercises, just mixing the two together just to know. Now, this is sigma not known. Now, from the title, it's going to be t-test. But you'll see later when I mix the questions, you should be able to tell right away which test we are using. So t-test, number 2. Okay, and let's see, mu 0. The value from the null hypothesis has to go there, so 125. X bar, just go, let me go to put it on the left, it's 120.3. Sorry. S is 10. N is 26. And now choose the sign from the alternative hypothesis, which is not equal, guys. And if you want,
First one, right?
Yep, that is correct. You can hit calculate. And look, T is negative 2.397 with 3 decimal places. And it says here p-value 0.0244. All right, I'm done with the calculator. Now I need to compare it with alpha. He says, what's the decision at the 0.01 significance level? That's alpha. You guys agree with me that this is bigger than alpha? Then what's the decision, first or second?
Fail to reject.
Okay, if you fail to reject, as I stated yesterday, guys, you start with there is not enough evidence at the 0.01 level of significance. Then if you're doing your MyMathLab homework, it's gonna tell you select reject or support. Where is the claim, guys? In HA. If you get the word reject and support, you select the word support because the claim is in HA. But we're not saying that we're supporting here. We're saying we're not supporting. There is not enough evidence to support the city of Bosman claim. So we could not support their claim, guys. That concludes the problem. Number 3, a credit card company wondered whether given frequent flyer miles for every purchase would increase card usage, which is currently at a mean of $2,500 per year. So the credit card company, guys, wanted to increase the usage of the credit card beyond the $2,500. They gave free miles to a simple random of 24 credit card holders, that's N, and found that the sample mean to be 2542. And look, guys, it says sample standard deviation. So that's S. Can you guys help me state the null and the alternative hypothesis here? Again, this is mean. When he doesn't mention proportion percent, it's the mean.
Greater than?
Greater than, yeah, because the credit card company are interested in making people spend more money than the $2,500 exactly. And that's less than or equal to 2,500. T-test, guys, again. All right, so let's run the t-test. Remember, we did that yesterday. We did this section, but we're doing more exercises. So 2,500. X bar is, let me just get the data, 2542.
Do you mind letting me see HO and HA?
Yeah. That's HO and that's HA. So what I'm trying to tell you guys, you're not gonna have clear wording in what you should do. They say they want to increase. You need to understand that increase means more than. And then S is what, 109?
So even like if it doesn't say they claim something.
Yeah, it doesn't. Well, it says at the very. They wondered whether given frequent flyer miles would increase card usage. So they put it in a different wording, but yeah, this is their claim. And we need to help them out to verify whether this claim, what they're wondering, makes sense or doesn't make sense. So we're gonna see if what they're wondering would work for them. So now the alternative, guys, we need greater than, watch. Don't you like this program, the p-value approach? Do it right away. Let's do a draw. I'll show you the p-value in action. Not much shaded. Okay, so T is 1.888, 3 decimal places. And p-value, I'm just using the p-value approach here. And here's the p-value, guys. Let me write it down, 0.0359. You know what, guys? I'm gonna change this 1 to 5%. Make a decision at alpha equals 0.05. What's a decision?
You're gonna reject HO.
Reject. The reason why I wanted to reject HO, so because if I kept the 0.01, guys, it would have been failed to reject it. I just want to show you how would you write a claim when you reject HO. You see, it makes a big deal what alpha is. Very, very important. So we reject HO because the p-value is less than alpha and state your conclusion. So there is, we don't say there is not now, there is, because you reject HO. Enough evidence at the 5% level of significance to, okay, now my stat lab asks you to choose reject or support. Which one would you, which word would you select?
Support.
Support, because the claim is in HA. We're supporting the claim.
Professor,
Yes.
so I'm kind of confused on like, so if the p-value or like, for example, the number is bigger than alpha, we support it?
No, we fail to reject HO.
That's if it's bigger, right?
Yes.
And then if it's
There is
lower,
there's no support or not support. In step number 4,
mm-hmm,
when
it's
the
just reject.
p-value is more than alpha, it's about HO. You either say I reject HO or I fail to reject HO. That's it.
Okay.
Yeah.
And then if it's failed to reject, there isn't enough evidence to support it, right?
Exactly. There is not enough evidence to support the claim. Yeah. So there is enough evidence at the 5% level of significance to support the claim that giving frequent flyer miles for every purchase, I'm just copying the language, guys, from here, would increase card users. All right. That is the conclusion. You see, guys, if I made this at 1%, it would have been there is not enough evidence at the 1% level of significance to support the claim that giving frequent flyer for every purchase would increase card users.
Could you show me what you entered into your t-test?
What we entered the following stat, let me just to go stat tests, t-test. So we enter mu0 as 2500. And then we entered X bar to be 2542, S to be 109, and N is 24 credit cards. And then you must, guys, you must select the alternative sign here, which is greater than. All right.
Thank you.
Yeah, you could do calculate or you can do draw. Calculate is fast. Look, guys, how fast it is. Remember, guys, when you go back to your notes that I changed this to 5%. The 5%, guys, is the maximum allowable probability of making type 1 error. It's better for alpha to be small, guys, but we make it 5% here. That changes even the outcomes of the problem.
So Professor,
Yes?
today we're just going to be learning like more in depth, right? Of
Yep.
what we did yesterday.
Yep. Exactly.
Okay, nice.
Yeah. A fast food outlet claims that the mean waiting time in line is less than 3.5 minutes. I don't expect any students to even make a mistake here. It says less than 3.5 minutes right here. That's the claim. A random sample of 15 customers, so N is 15, has a mean of 3.4 minutes, 3.4, with a standard deviation of 0.6 minutes. That's S. At alpha equals 5%, test the fast food outlets claim using, don't worry about using confidence interval, just using p-value. Assume that the population is normally distributed. T-test, guys. And let's go back. The t-test is very, very important, more important than the z-test, for a simple reason, because in real life, we don't know what the population standard deviation is anyway. So I would just go to stat, tests, t-test. Mu0, guys, I have to change it to 3.5. And then I'm gonna go here and copy the information. So we get 3.4. S is 0.6. N is 15. And which sign do we select as first, second, or third? Can you tell me?
Second.
Second. I agree. And let's do a calculate here. So that's T negative 0.645. P-value is, let me show you what I got from the p-value, 0.2645. It's a huge, which is bigger than alpha. So the decision will be fail to reject HO. And if you fail to reject HO, this is what you write in step number 5. There is not, you see, fail means not enough evidence at the 5% level of significance to, okay, now we need to select the word support or reject. Since your claim is in HA, it's going to be the word support. But we're not saying we're supporting, we're saying we don't have enough evidence to support. That means we're not supporting to support the claim that the mean waiting time and line is less than 3.5 minutes. So you can go, guys, and tell the fast food outlet claim, the outlet, that you're making wrong claim here. And people can get in trouble, you know, just if you can justify, you know, just that what they're advertising is wrong. That the mean
Just a quick question that's not related.
Mhm.
The H of A would not equal to be one of those. 'Cause
What
I
is
know
it?
it's HO, like equal to would be a HO or at least or at most, but not equal to, would that be a HA type of statement?
100%.
Okay.
Definitely. Definitely. Any statement that doesn't have an equal sign is an HA, and these are the 3 of them. This is HA. And these are their complements. So you always have to have these 2 together, or this pair together, or that pair together, always. Yeah, definitely this is an HA. Yep. Next question. This is when you're going to use lists, guys. The Carolina Tobacco Company advertised that its best-selling non-filtered cigarettes contains at most 40 milligrams of nicotine. But Consumer Advocate magazine ran tests of 10 randomly selected cigarettes and found the amounts of nicotine. It is a serious matter to charge that the company advertising is wrong. So the magazine editor chooses a significance level of 0.01. Can the editor prove that the mean nicotine level is greater than 40 milligrams? That's the question, guys. Follow the question in the problem statement. Okay, how would you state the null and the alternative, guys?
So I was gonna say the null was what the tobacco company said. But you're saying-
Exactly, and that is, but that's not the question. The question came from what the news editor. He wants to verify if it is greater than 40. So this is where the claim is. The tobacco company are not doing anything, and they're not trying to prove, just what they're doing. They know that this is how they do business, but somebody else is getting suspicious, and that guy, think the magazine editor thinks that the amount of nicotine is more than 40 milligram, and that's what we need to check.
Okay, but the null doesn't switch in that case. It just
No,
stays the null.
it stays the same. Yeah.
Okay, got it.
Okay. If you give a list, guys, you put it in L1, and that's going to be a t-test. I already have the data in L1. Let me show you. I put it in L1 already. You know how to do that. You go to stat, edit, and just enter it. And now we're going to go to tests. T-test. Data. I need to select data. Mu0. Okay, we have to assume the null hypothesis is true until proven otherwise. Remember, we assume that the defendant is not guilty until we prove otherwise. The same thing for hypothesis testing. We assume that HO is true until we can prove that it's not, if we can.
I have a question.
Mm-hmm.
Why are we using the t-test over
Okay, that's a good question. Did anywhere in this problem statement mention population standard deviation?
No.
That's it. It's a t-test.
Okay, because I feel like I was just working on a homework problem and I used the z-test, but I don't remember.
Let me tell you, yes, I agree with you. There was a question in the homework problem in your section 7.2 where he gives you a data set, but he mentions within the problem itself that we know that the population standard deviation is blah, blah, blah.
Okay.
That's
Yeah, the one with like 30 data entries.
Exactly. That's the one. So you're right. But if he doesn't mention it, automatically it's a t-test.
So, Professor,
Yes.
if we fail to reject HO, then there is enough evidence. There's not enough evidence.
Yeah.
To support it. And then if we do reject it, there is enough evidence.
No, if we fail to reject HO, there is not enough evidence to support the claim when it is in the other one in HA. Because
Okay.
when you have two statements, when the first statement you're saying probably the first statement is not wrong, then you don't have good evidence for the second statement. That's what we're trying to say.
Okay.
All right, guys, t-test. Let's run the t-test. So as I told you yesterday, guys, never touch the frequency. It's always at 1. Now I need greater than. Remember to switch, and don't just, even if it blinks, guys, it doesn't mean that you selected it. Press enter. And let me do a draw here. So your p-value is going to be on the right now. You're going to see the p-value in action on the right. Watch. Oh, not much p-value. Let's see. So T is 2.746. And the p-value is 0.0113. Okay. And alpha, guys, is 1%. Let's go to the next page. I will PDF those notes and email them to you later today. All right. So let me write the p-value.
Would it be considered slightly larger? I mean,
Yeah, but I know what you're trying to say here. It is slightly larger. Yeah, then it is more than alpha. The question is, they're very close. So we're probably, our decision, is a bit, just consider probably inconclusive, but we're just going to follow the fact that if p-value is more than alpha, we fail to reject HO. Just follow that. So you guys agree with me that we have to fail to reject HO. Probably some students were wondering why we say fail to reject and instead we don't say accept. Remember, if you fail to reject something, it doesn't mean that you accept it. You fail to reject an argument, it doesn't mean that you accept your argument. Sometimes it means that you just give up and without acceptance, just said, okay, I'll go along with you. Although I don't agree, but I'm gonna go along with you. So
Wait, so there isn't enough evidence in this case? Because
yes, to support the claim. There isn't enough evidence at the 0.01 level of significance to support the claim by the magazine editor that the amount of nicotine is more than 40 milligrams. So this guy can get in trouble now.
can we backtrack a bit? Because I thought I thought that's what we just proved by saying it was more than alpha.
More than alpha means you fail to reject HO, right?
HO is
It's this. So the HO is what the company advertises, right? At most. So that
Yeah, at
means
most.
probably the company is right and the editor is wrong. And what we're saying here, we're saying we cannot support the editor's claim. Look what it says here. We don't have enough evidence at the 0.01 level of significance to support the claim by the magazine editor. If you guys cannot reject HO, just keep this wording in mind. If you cannot reject HO, then you cannot support HA. The only way to support the HA, guys, that if you reject HO. Because if you reject, you guys, the first statement, if you say that this is bad, I'm rejecting it, that means your second statement is good. Does that make sense?
Kind of. Okay, so alpha basically in this problem is it's lying with the H.
Alpha is just used to compare it with the p-value.
Okay. All
Just the p-value, just the p-value. Look, I compared it here. Do you see what happens if alpha was 5%? What would have happened if alpha was 5%, guys?
Then there would have been enough evidence.
Well, then we reject HO, then we've been enough evidence to support the claim. You see, alpha is a big deal here. Once you, like FDA, guys, for I think the COVID vaccine, they require alpha to be 1%. They want all the studies to be 1%. They want the chance of making a mistake of type 1 error to be as small as possible. So I think they required alpha to be 1%. They wouldn't buy any studies on alpha being 5 or 10%. I think it is a 1%. All right. Now, testing a claim about the population proportion. I ended my class yesterday with one example on the population proportion, and let's do more today. And you guys are gonna see the same 5 steps. So you're gonna get to become more and more familiar, just with the concept as we do more problems. The engineering school at a major university claims that 20% of its graduates are women. In a graduating class of 210 students, that's N, 46 were women, that's X. Does this suggest that the school is believable? Use alpha equals 0.05. So the school is making a claim that the percent of women who graduate from the engineering school is 20%. Who can help me write HO and HA?
HO would be P equals 20.
You got it. Excellent. And that's, you agree with me that this is the claim? Okay. When it comes to proportion, guys, there is no confusion here. No decision, do I use this test or that test? There's only one test. It's called the proportion test. And I'm going to show you this test right here. You go to stat. Yes, it's number 5, guys. That's the only test. One prop Z test. Okay, let's take you there. Okay, P0. P0 means state the value that you have in the null hypothesis. So 0.2. X is a smaller value, 46. N is 210. And now choose the not equal sign. That's the alternative. And if you want a draw, oh, huge p-value. So you need 2 values from there. We need this one, Z, and we need a P. So I'm going to copy them, 0.69. When you do your homework in my MATLAB, there are prompts and fields that ask you, what is the test statistic? You do that, and then you move to the next part. P is 0.4902. I like to write a p-value there so students know we're talking about the p-value. And I'm done with the calculator here. And what's the decision here, guys? Do you guys agree that this is bigger than alpha? Of course. So what would be the decision?
Fail to reject.
Yep. And that's right. Would a student like to interpret?
There is not, first of all.
Okay, give me the whole thing.
There is not
Enough
enough evidence to suggest
at
the whatchamacallit, where is it?
5%.
Yep, 5% significance level that the school.
Okay, let's make it easier. Either I want you to use the word support or reject always. So since the claim is in HO, we have to use the word reject. So there is not enough evidence at the 5% significance level to reject.
So whenever it's at HO, that's what we state, or does it
That's where we
change?
use this word, exactly. When the claim is at HO, you use this word. When the claim is at HA, you use the word support. When you
Got it.
reject HO, you say there is enough evidence. When you fail to reject HO, you say there is not enough evidence. It's as simple as that, guys. And if you follow this pattern, guys, I can guarantee you will never make a mistake in the final statement.
Professor, can you say that one more time so I can write it down in the notes?
It is at the very end. I've said it, just at the very end of this handout. I will show it to you. But what I'm saying, if you reject HO, you start with there is enough evidence. If you fail to reject HO, you start with there is not enough evidence. Now here it comes to picking up one of 2 words, reject or support. If your claim is in HO, please select the word reject, guys, here. And if the claim is in HA, select the word support. That's it. To reject the claim by the engineering school. We are saying, guys, that we cannot reject their claim. So do you think the school is believable? Yes or no? If I don't
Yes.
reject your claim, guys, that means probably you are believable. Yes. The school is probably, yeah, is probably believable. Can confirm that. I can never confirm it, but I'm probably right. When you guys make a claim and I cannot reject your claim, so probably you're right. That's what I'm trying to tell you here. Next question. Any Boston Celtics fan knows that Shaquille O'Neal, one of the NBA's most dominant centers for the last 20 years, always had difficulty shooting free throws. Over the course of his career, his overall made free throws percentage is 53.3%. So what we know about Shaq, that when he makes, just free throws, he hits 53.3% of the time. During this offseason, Shaq is working with an assistant coach on his free throw technique. During the first 5 games of the next season, Shaq made 26 of his 39 free throw attempts. So he did 39 attempts, he hit 26 times. Do the results provide convincing evidence that Shaq has significantly improved his free throw shootings? Carry the test at 5%. What do you
This one,
think?
are we doing P?
Yes, it is a percentage. Who can tell me what we're testing here?
P equals 0.533.
And what's the other one?
P does not equals 0.533.
But let
No,
me
greater
tell
than.
you, he used the word improve.
Greater than or equal to, or no, just greater than, right?
Later, exactly. The students who said equal, not equal, I can see your point. But here he's saying improved. Does that make sense to you that improved means greater than?
Claim is an HA, right?
Yeah,
All right.
exactly.
You get it wrong if you're not paying attention, basically, to the question.
Yeah, you have to read every single word in the question. When he says improve, it's a plus, greater. When he says reduce, for example, it's a less than. So, and guys, we have n is 39 and x is 26 and alpha is 0.05. That's all I need. So I'm going to move you to the next page and show you what's happening there. So I'll write the steps one more time.
So the N was how many free throws he shot?
Yeah,
Okay.
yeah, the attempts. It's a number of attempts, and 26 is a number of successes. The n is always the bigger numbers, so you can't just think about it this way. One prop Z test, guys. All right, they're ready. Is that?
So Professor,
Mhm.
we're right now for this chapter, we're only using Z test, T test, and one prop Z test.
That's it.
Only those 3, right?
That's it.
Okay.
Yep. We're trying to make it simple on you guys. So X is 30, what was it, 39,
Yeah.
26. Oh, sorry, I mixed them up. I would have gotten an error here. And now we need to check it greater than. If you guys want to take screenshot of this while I'm doing that, that's fine with me. I don't mind, just to know how to. And but if you promise you'll go back and redo the problem, guys, the best way to learn is, I know, guys, you're listening to me. The stuff will make sense to you as I explain it. But the challenge is just to go back and redo the whole thing on your own. That's what I want you to do.
Do you mind if after the class I just ask a couple of questions? Because like I told you before, the last 2 chapters I kind of messed
Let's
up
pick
on.
around. Yeah, I can,
Yeah.
yeah, sure. So let's do, for example, a draw. Okay, so Z is 1.67. P-value is 0.0471. And we're using alpha 5%. So you guys agree with me that this is what? Less than alpha, correct? And what's the decision, guys? Reject HO or fail to reject HO?
Reject HO.
Reject HO. Don't mix them up. It's a reject HO. And let's write the conclusion. And I'm gonna follow, guys, my techniques of writing the conclusion. I'm not gonna come up with new ideas, whatever I've been doing. So if we reject HO, I told you earlier, you start with there is enough evidence at the 0.05 level of significance. 2. Okay, where is the claim, guys? In HA. And what did I say? What word do I use when the claim is in HA when I state the conclusion?
Support.
Yep. I'm not gonna change that ever to support the claim. So that means that Shaq is benefiting, just from this extra training. To support the claim, if you want to just see what the claim is, guys, you just copy and paste the language. That Shaq has significantly improved his free throw shooting. All right. Let's do one more with this section and conclude section 7.4 there. A drug manufacturer claims that if you see, just follow the claim now. Fewer than 10%. Who can interpret fewer than 10% for me?
Less than 0.1.
Yep. So you guys know already what to put there. And then the null hypothesis, it's going to be the other side. Less than 10% of patients who take it's a new drug for treating Alzheimer's disease will experience nausea. So they're saying people who take, just their new drug to treat Alzheimer, only less than 10% will have nausea as a result of a side effect taking the medication. In a random sample of 250, 23 experienced nausea. Perform a significance test at the 5% level to test this claim. Again, guys, it's one prop Z test. All right, let's perform the test.
Is PO at this one 10%?
Yep,
Okay.
it is 10%. So 0.10. Let me just move to the other side. 23. N is 250. And now we need less than. You make sure to select this properly, otherwise you will get the wrong p-value, guys. So less than. And hit calculate or draw. Oh, huge. So Z is negative 0.42. You see, guys, the 5 steps. P-value. In the book, you might see 6 steps. One of the steps is to state what alpha is, which we do it by default always. P-value, guys, you can see the p-value here. It's 0.3366.
It's more.
Oh, definitely. So we know what the decision is. When you fail to reject HO, you can't support the claim when it is in HA. So we're going to say
There is not.
not enough evidence at the 5% level of significance support the drug manufacturer claim. That's a big deal, guys. They're putting false advertisement probably about side effects. And if you want to write the claim, you just say it, that fewer than 10% of patients who take the new drug for treating Alzheimer's disease will experience nausea. So
On that last one we did when it was reject. I'm just trying to make a connection here. What did it change again when it was there's not enough?
there you just didn't put the word not. Then you support the claim.
Okay, got it.
Yeah. Again, guys, this is just in summary. Look, this is it. You have these two competing, these are two, you agree with me, these are two competing hypotheses. They're total opposite of each other. If one prevails, the other one will fail automatically. So when you say you reject HO, guys, when you say I'm rejecting this, that means you're supporting the second one. But when you are saying I cannot reject HO, fail to reject HO, then you're saying here you cannot support HA. That's it. That's all in there. So here, since we failed to reject HO, there is not enough evidence at the 5% level of significance to support the drug manufacturer's claim. Now, one thing I would like to bring to your attention here, you might see that in the homework online. We're asking you to perform the test. There are probably one problem or two in the homework online. I'll ask you to check if the conditions of the test are met in order to perform the test. And let me tell you what the conditions of the test are. In order to perform a 1 proportion Z test, there are 2 conditions that must be met. And let me tell you what they are. The first one is N times P must be bigger than 5. And N times Q also must be bigger than or equal to 5. And let me show you how to verify that. N is 250. We already have it. P is the value that you pick from the null hypothesis. So 0.1. So you just do, guys, 250 times 0.1, which is, guys, you agree with me, it's 25, which is bigger than 5. So the first condition is met. And who can tell me what N and Q are? What goes in here? That's
0.9.
0.9, very good. And what is this going to be, guys? 225, which is bigger than 5, met. If he ever asks you to verify the condition and you cannot support that both of them are met, you don't continue with the hypothesis test. You say we cannot perform the hypothesis test. But you notice in all the questions that I put in there, I said perform the test. So I'm already assuming that the conditions are met and I'm asking you just to perform, the test. But these are the 2 conditions, guys, that you need to be aware of. Now, the other 2 for the Z and T, let me just elaborate one more time on Z and T. And I think actually the book, let me just 1 second. The book uses a nice flow chart to show you, just the breakdown. Just For the Z and T test, guys, ask yourself if sigma known, if it is given in the problem. If it is a yes, use Z test. If it is a no answer, use T test. It's as simple as that. Now, if the population is bell-shaped, guys, if normally distributed, any sample size would do it. Doesn't matter what the sample size is. But if the population is not bell-shaped, sample size has to be greater than 30. That's from chapter 5. N must be 30 or more. So if he gives you a population that is not normally distributed, and he give you N to be, let's say, 20, he will not be asking you to perform a hypothesis test. He will be asking you probably, can we perform the hypothesis test? The answer is no, because N has to be 30 or more. But if the population, guys, is normally distributed, it doesn't matter what the sample size is. It could be any sample size. So we're gonna continue, just with to do some more problems here. Let me see, we're at 8. Additional exercises, guys. That's a mix now. So we learned about 3 tests, Z test, T test, and 1 prop Z test. Now I'm gonna have you guys tell me which test do we use and whether it is a proportion or a mean. And then I will end, the last 10, 15, 20 minutes of discussion talking a little bit about the critical value and section 7.5. So let me just quickly walk you through those problems and at least tell you which test we will be using on those problems. An airline claims that no-show rate for passengers is less than 5%. So would you guys agree with me that HO and HA will be less than 5% here, claim, and here will be greater than or equal to 0.05. In a random sample of 420, so N is 420, 19 were no shows, test the claim. Are we all in agreement, guys, that this is 1 prop what? Z test. Yes? Okay. I consider your silence as a consent that it is a yes. Okay, let me just go to the next question. And now tell me which test do we use here. A local group claims that the police issue more than 60 speeding tickets a day in their area. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The data are listed below. At alpha equals 1%, test the group's claim using p-values. Assume that the population is normally distributed. You see why he says assume the population is normally distributed, because he gave me a small sample size, 1, 2, 3, 4, 5, 6, 7, 8, 14. What would be the null and the alternative hypothesis, guys? Who can help us?
The null would be that it's less than or equal to 60.
That is correct. You are correct. And that's a claim. And guys, this is a t-test. But before you run the t-test, you have to put those values in what? L1 and run the t-test. Okay. Let's do another one. That's a good one. It did confuse a couple of my students this morning, but one other student was able to pick this up. A local brewery distributes beer in bottles. labeled 32 ounces. So they're supposed to put 32 ounces in there. A government agency thinks that the brewery is cheating its customer. The agency selects 26 of those bottles, so N is 26. Measure their contents and obtain a sample mean, X bar, 31.45 ounces, and a standard deviation S with a sample standard deviation of 0.65 ounces. Use alpha equals 0.05, guys, to test the claim if the A brewery is cheating its customers. How would you express the cheating claim as in HO and HA?
HO is the local brewery giving the 32 ounce, so equal to 32. But then the claim is the agency's claim.
You have to put the simple mean. It's the average amount.
Mhm.
Okay, what will, so you say equal and not equal? Is that what you would say?
Yeah.
I would have to argue here that cheating doesn't mean not equal, no. Because not equal 32, they could give you more than 32 ounces in the bottle. That's not cheating. That's they're being generous here.
Okay, so it could be
You know
greater
what
or
I'm saying?
equal to.
Yeah, that's the claim, guys. If you guys cheat me when it comes to weight, that means you're giving me a lot, like I'm buying something from you, just, and that requires, just you do a weight. If you are cheating, you're giving me less than what you should be giving me. So it is less than 32 ounces. That's cheating.
Wait, well, I thought the oh, okay, never mind. Yeah, that's the government agency's claim. Never mind.
Yeah, not the brewery. The brewery is saying they're not saying that they're cheating. They cannot never claim that they are cheating. It's a government agency. So guys, does it make sense that cheating means you get less than what you paid for? That's exactly what cheating is. So this is a t-test. Let me just do this one. T-test, stats. mu0 is 32. X bar 31.45. S guys is 0.65. N is 26. And less than. Yeah, some of my students this morning said equal or not equal, also the same thing. But I had to convince them that it should be the less than. Okay, so negative 4.31. Let's write the p-value, guys. That's very important that you interpret what you see on the screen. You see the e minus 4, guys. The e minus 4 means that you have to move this decimal point 4 digits to the left. So it's going to be a 0.0001. P-value low, HO must go. That's less than alpha, of course. So reject HO. What's the conclusion, guys? Can you help me here? There is enough evidence at whatever the significance level is, it's gonna work at the 0.05 level of significance to support the claim. Is it clear why I'm using the word support, guys? Because the claim is in HA. That the brewery is cheating its customers. Or the mean the mean amount, just of beer is less than 32 ounces. So I think the brewery will be in trouble, legally in trouble, guys, now, because you were able to support the claim that they are cheating. This is how they do business, guys. This is how the FDA, just checks claims as well. So that's one approach. They probably select more than 26, just bottles of beers. They do probably more than 26, but we're doing 26 in this example. Number 4. According to official census figures, 80% of couples living together are not married. A researcher took a random sample of 400, so N is 400, and found that 39 of them are not married. Test at the 5% significance level if the current percentage of unmarried couples is different from 8%. So can you guys tell me what the null and the alternative are?
P is not equal to 8.
Yeah, as simple as that, guys. I mean, it's obvious. And this is one prop Z test. So if you do those exercises today, guys, come back tomorrow between 10 and 11:30 and just ask me to verify whether your answers were correct or not. I'm just giving you the hints here. Next one. A sample of 1,600 items produced on a new machine showed that 97 of them are defective. So that's N. When there is no mention to standard deviation, guys, this is a proportion. The factory will get rid of a machine if the data indicates that the proportion of defective items is significantly more than 5%. See, more than. That's the claim. So that's a prop C test. And this is alpha. We just run a prop C test. An expensive restaurant claims that the average waiting time for dinner is about 60 minutes. But we suspect that this claim is inflated to make the restaurants appear more exclusive and successful. A random sample of 32 customers, N, yielded a sample average waiting time of 50 minutes, X bar. The population standard deviation for waiting time to be seated at a restaurant is known to be 10 minutes. So you guys agree that this is sigma? It says population standard deviation. Is there evidence to say that the restaurant's claim is too high? How would you set up the null and the alternative, guys?
Isn't the restaurant's claim the null? Or no?
Okay, I need the claim with that simple mean.
Yeah.
Less than or equal to 60?
They claim it is 60. We think that this is inflated.
Greater than?
No, inflated means it should be, because we said it's inflated to make the restaurant appear more exclusive. You know, guys, when you advertise a restaurant, say the wait time is 2 hours, that you would think, oh, wow, this is a high-class restaurant that I should check it out because everybody goes and willing to wait so much time in order to eat there.
So less than.
Exactly.
But it says approximately. Wouldn't that suggest that it's,
No, I mean, we can never be exact on time. That's why we put the word approximately.
okay, so that doesn't change anything in regards
it
to this
doesn't.
thing.
I see your point, but it doesn't change anything. All what we think, they're telling us it's 60. We tell them, no, I think you're inflating this. It's less than 60 minutes. And you guys, that's the claim. It's not the restaurant to claim. The restaurant claim is in here. Our claim, it's the what we suspect. And what test do I use? You get X bar, which is 50. You get sigma, which is 10. You get N, which is 32. And you have alpha, which is 0. What was alpha? We'll use 0.05. Okay, what test do I use here, guys?
Z-test.
Z-test. Is it clear to students why it's not a t-test now? Because
The
of
sigma.
because of this. Okay, he says the original data individual waiting times is not bell-shaped. Can we still perform the claim? What theorem allows us to still do the calculation? Because the sample size, guys, is more than 30, we don't care if the original population is bell-shaped or not. It's called the central limit theorem. That's what we learned in chapter 5. All right. It seems a lot of students think that they can manage without attending the lesson. Anyway, I hope so. Half of the class is not present today. That's a bit disappointing. We'll see. Question 7. In a survey of 1,273 adults, 668 said it is not morally wrong to change the genetic makeup of human cells. Can you support the claim that majority of adults do not think it's morally wrong to change the genetic makeup of human cells? So this is, guys, N, and that's X. And what would HO and HAB? Please mute yourself when after you talk. I can hear the echo here. All right. Majority, guys, means percent. It's a proportion. What would that be? What did we define majority? More than what?
50?
Yep, that's majority. Majority, let me write it down. More than 50%. Let me put minority. If one time you have a test to test that, it is a minority.
So this is kind of like the default unless it says otherwise.
It's always the default. That's
Just-
what majority and
okay.
minority means. Yeah. And less than or equal to. And alpha is 10%. So you get N 1273, X is 668, and it's one prob Z-test. Question 8. It was found that 821 crashes of mid-sized cars equipped with airbags, 46 of the crashes resulted in hospitalization. So that's N and that's X. You see lots of proportion problems. Use a 0.01 significance level to test the claim that the airbag hospitalization is lower than the 7.8% rate for cars with automatic safety. That's very straightforward, guys. It's saying lower. This is the sign for lower. So you should be able to easily, and I would change it to a decimal here. And so N is to 821, X is 46, guys. Let me just do this one. And that's the claim, definitely. I intentionally did many problems when just wanted the claim to be in the alternative because most of the time it is in the alternative. So 0.078. Okay, now X 46. N, guys, is 821. Less than. And then calculate. So Z is, let me just, you can see the Z, guys, negative 2.35. And the p-value is 0.0095. And you guys agree that this is less than 0.01, of course. So we reject HO. Remember, step number 4 is about whether you reject HO or fail to reject HO. Don't mention the claim at all in this step. Now we mention the claim. There is enough evidence at the 0.01 significance level to what? Who can tell me the word?
Support the claim.
Support the claim, yeah. We can support the claim. We can, C-A-N. Support the claim that the airbag hospitalization. So that means probably it is safe to use airbags. Yeah, that's what the problem is intended. It's lower than the 7.8% rate, or it hasn't increased at least for cars with automatic safeties. And I'm just copying and pasting, guys. I'm not doing anything new. I'm just copying the claim. All right. This is a summary of the sections, how to use the calculator in each one, the steps with directions and steps, how to use the calculator. And for students who ask me, how do we write, the conclusion at the very end? Look, this is for step 4. And this is, guys, for step 5, the 4 scenarios. Just read them carefully. This is what I've been using. What do you say if the claim is in HO and you reject HO? What do you say if the claim is in HO, you fail to reject HO, etc.? These are the 4 statements that you have to use in every single problem. Okay, what I would like to do now, guys, just the last, so let me just stop this.